So for this today's lecture, so I will just try to give you the brief idea what it is going on in Earth observations and with the innovations and which is going on in AI, okay, and how these applications basically using the AI in remote sensing nowadays is growing up, okay. So that the field, the real world field and scenario which we will try to give you the idea. So most of this my analysis which I did actually with the help of the ISRI products, okay. So because previously I was working for the ISRI for a long time, okay, so almost 7 years now, generating the different kind of AI tools which is already available or which we can modify it with the different kind of scenarios. So that's what which we'll try to explain you over here in this particular lecture. So if anyone is interested in future, like once you pass out, like what kind of skills, what kind of area which is actually innovating, okay, so that's I will just try to cover in this particular lecture. So now if you see here, there is a different way if we divided it, this particular lecture, okay. So what are the areas where the innovations is come to the picture? So first I just make it in 5 different characteristics, okay. So if you see, first one is C. So like a computer, you can say the vision or the object recognitions, okay. So that is what we can say usually we can apply the AI and machine learning applications over here, okay. So the object detections, if you basically see these identifications of the different kind of buildings and other information structures, we are focusing through the AI is how we're going to extract it, okay. So that is the one part which we're going to see. Now there is another options is you see in here, that is the car is moving, and what is this? Basically the object tracking, okay. So tracking a moving vehicle and objects over a time, okay, like suppose some specific you can say the aircraft, and the similar kind of technology we are actually applying to see the wildlife movements, okay. So these are the areas where this AI technology is extensively is going to use nowadays, okay. Now there is a part that is land cover classifications. If you see AI based classifications is nowadays came very fast, like in ISRI we are actually going to use, suppose the Landsat, it is very commonly we are actually using Landsat, Sentinels, okay. So this kind of common satellites, okay, if you created a specific kind of land cover type, not land use exactly, land cover, if you see land cover classifications types, so is possible to do by automations, okay. So using we can do the classifications, and this model is already there, okay. People are actually using this. Yeah, there is a kind of accuracy level that we will come to after some time, okay. But yes, this model is already available, and people are actually working on this particular land cover classification techniques. Now there is another part which is called as a read, so where we are actually using the AI technology again, okay. So first is the entity extraction. So entity extraction is basically the identifying the extractions with the meaningful informations, okay. And some cases there is another thing like a text classifications, like in the image there is some kind of text which we need to extract, and we want to create it as a separate object, okay. So there also we are actually using the deep learning AI machine learning tools, okay, to extract this informations. Now there is the another part, like where that is we called as an analysis part, okay. So this is a very crucial part which we are actually, means it is a continuously development is required, continuous knowledge is required, okay. So then only you will get a good results and which you can able to do the analysis. So first is the prediction. So a lot of the AI tools which is based on the prediction model, like AI models is basically forecast you can say the environmental changes, okay, as well as there is a kind of a clustering, like see some objects will be there which we are actually using the clustering technique to extract the object. Just here there is one example which I given here, that is for the cloud extractions, okay. But the similar kind of things which we are actually using for some other objects also, like we used one project in Assam forest, that is basically the what is called tree canopy extractions, okay. So that is we are trying to like here in India there is a big challenges to separate the canopy, but the canopy areas models, yes, we are successfully extracted that particular thing. But if it is like in UAE, when we are working for some Plamty project, so individual canopies very easily we can extract. But it just depends. Again, it is like country specific. The deep learning model should require more improvement. Okay, it's not like a single model can applicable for all the worlds. Okay, so it's not possible, and that is what in geospatial industries the main challenges which is we are facing as of now. Now there is another part is the forecasting. So in case of the forecasting also, this AI technology is hugely used for this particular purpose. Okay, and then some cases we are actually using the automatic relationships we will try to build. Okay, so if there is any kind of model which can create automatic relationship and take a meaningful informations from the image, so that is kind of a regressional based analysis also in automations which we are actually using. So it's an AI driven statistical model from the trained analysis, like from the past image and the present image, how we can predict it. Okay, so that is how we are actually using the regression model. Okay, so which we are there in ISRI separate deep learning package module, you will find that particular tool. Then model expandability. So this is another understanding of the AI model discussions using the visualization tools. Okay, different kind of data visualization techniques, both over the 2D and 3D. There's a different techniques will be there which we are trying to visualize the data to get a more meaningful informations from the image. Okay, so for the visualization also nowadays we are actually trying to use the AI. Okay, to make our work more faster, and data should be more explainable. Okay, more understandable. So that's what we will try to do it over. That is another area which analysis part which we are actually focusing. Now there is a part of the learning. Okay, if you see there is a like here, if you see we are actually using deep learning studios like AI powered platforms for the training models on the geospatial data. So that is already there. Okay, you can directly take that, okay, and you can use it as a geospatial tool. Just like here is one example we are giving as a GeoAI toolbox. Okay, in ArcGIS Pro we have this particular toolbox. What is this? Like whatever the tools which we are actually telling you, that is the individual DLPK files which you need to download, and then you have to process, okay, in your ArcGIS Pro. Okay, but if you have the GeoAI toolbox, okay, so then all this you can say the DLPK package library, okay, it will attach in a one single tool. So you need not to go and move to search about the different types of deep learning tools. So that is the another advantage you will get over this particular tool. But yes, obviously there is also a separate extensions which is required to process this data set. Now there is some cases we are actually using the AI assist labeling, like automated automations of the geospatial database for the training and AI models which we are actually using. Okay, so that as you've seen here, okay, like to generating the labels, it is basically very important technique to do that. Now the last area which is basically the create, which is related to the enhancement, pre-processing over the data sets, mostly the enhancements and the reconstructions. Okay, like one example like super resolution is basically the reconstruction tools. Basically, see, suppose we have some cases Landsat or the Sentinel, we have the limitation of the resolutions. Okay, like Sentinel will get maximum 10-meter resolutions, or Landsat we can make maximum 30-meter resolutions. But some cases we want the better resolutions, okay, to identify some objects or to enhancing the visualization capabilities. Okay, then super resolution is one of the AI techniques where we are getting the enhancing those coarse resolution satellites in a higher resolutions. Okay, but obviously there is, again, it is a questions like when I am using these tools, and I just tell and asking the people who are actually creating that is it saving the spectral property of the data? No. Again, it is no, big no. Like in LinkedIn very recently I saw a post on this. They are creating some increase the resolutions and over the wet, and he is trying to identify the wet field. But when I asking him like, are you did the validations over this, okay, to prove this particular model, then there is no reply. So that means that is again the questions like of the capabilities of the AI and deep learning models. It's not like that it can suitable for all the area, but what the technology is going towards the future. Okay, so I'm definitely sure maybe in future it will be possible, but as of now the AI is required more trainings. Okay, so data and the labels, so that the capability of the AI will increase more. Like here one of the example is you've seen here is a cloud removal. Okay, so as you see the cloud removals, there is a different techniques will be there which AI can do very easily. But what techniques it is actually using? Is it using the masking? Is it using mosaicing to cloud removal? Okay, so all the techniques which I mentioned here, even the pixel editing technique is also there. These three techniques which usually I do for a different spaces when I working for. So we are using these three techniques. So these three techniques is possible to remove the cloud in a very good manner. But is it save the spectral property, whatever the crops which will be there, we can 100% accurately extract the information from that? No. Again, it is a big no, because it is a rule, like whenever we have the 10% clouds, we can accept that particular image for our analysis. But if it is more than 10%, we are usually not use those particular data. But nowadays there is a kind of a situation like disaster. Okay, there is no other options. If you don't have any sentinel SAR images, then we have to move to the multispectral. So in that case we require this kind of technology to remove the cloud and do our target informations to extract. Okay, so all are based on the three important thing. One you see, like one is basically the pre-processing. Okay, so second one is the object enhancement technique, third one is basically the targeting, and fourth one is the extraction. So this is all how the remote sensing we are actually using these AI tools. Okay, so now I move to the next a very important slides. Okay, so if you see this artificial intelligence, it's like a broader term. Okay, so it's a broader term field where the machine learning designed to think, learn like a human. Okay, so with AI, the machine learning where the computer improve by the learning from the data instead of the following the fixed rules. So now going in a deeper, okay, so we can go for suppose the deep learning models. Okay, so which we uses the complex network. Okay, so similar how our brains can work or can process, okay, the large amount the informations that maybe the powering the things like voice assistance. Some cases we are using the voice assistant, some cases we the facial recognitions. Okay, all these things which is coming under the deep learning models. And then there is a more advanced, like you can say that is foundation models. Okay, this is some specific model like GPT is also there, like BERT is like it is also there, which is actually a powerful AI tools. Okay, so they are actually trained to extract information from the massive data to understand and generate the text. Okay, now there is a more advanced that is we can call as a multimodal models. As you've seen here, there's the last one. Okay, so it's like clip is there, CLIP clip, there is one model tools will be there. Okay, so which can process both the text as well as the image together, allowing the AI, okay, which is starts broad and gets more specializations for making the smart technology more power and useful for their daily lives. We will give you some example of that. Okay, so which is already came. So in general, okay, so this is the idea about how this AI, machine learning and deep learning, all which is coming very close to each other. Now we come to the integration types. Okay, so data integrations. Okay, so this slides is basically explained how the different types of the data we are actually using the geospatial, you can say the technical industry, we are actually using the different types of the data, like creating from the imagery, okay, like maps and scene. If you see here, so from the imagery what kind of informations we will try to extract. So like if you see this image, okay, like here like very recently I have involved in the project which is basically we will try to understand the farm health condition, farmland crops will be there. We are actually trying to understand the health scenario. So what are the processes? Like as we are taking the help of the AI, so before that we have to think like how, means as a human, as a data scientist, we are actually trying to extract the information, then only we can make some automation technique. So similarly here, for the farm, there is a different approach will be there. If it is a drone data, if it is a satellite imagery, whatever it is, a satellite imagery, then what is the different resolutions, then the important is the spectral bands. Okay, so if you have this type of high resolution image with a higher spectral bands, then we can go plot level disease identification or the crop stress identification techniques. Very recently, if you see one of my lecture I just given in YouTube, okay, so there is one hyperspectral data, like is waveRAN hyperspectral data is freely available. Okay, so that we can use a lot of this kind of studies, okay, where we can identifying the crop stress, okay, in a different level, and then we can develop some kind of AI tools which can identifying for this specific disease if you are already able to identify. Okay, so that is how the imagery we are actually using for the information extraction. Next one is the multidimensional data. Multidimensional data, you know what, like is kind of a time series data sets. Okay, so when you have the time series data sets, then there is a more chances to understand the trend, okay, and you can do the predictions for the future also. So that is the kind of data sets which we require the AI application should come more. Okay, because when there is a number of satellite data sets is a huge, or you can say there is a so much time period data sets which will be required to analyze. Okay, for the manual intervention, if you do it, it may take more time, but if you do with the AI, we may get the results in a very quick, faster mode. Okay, so that is what the AI, the multidimensional data sets is required more importance nowadays in the geospatial industries. Okay, so this is what the kind of a data sets is important, which I am telling you. Now there is a tabular data sets, like tabular data which we collected in a field. Okay, there is a lot of things is required to pre-process, make the data sets and ready. So in that case, if you take the help of the AI, so it can automatically organize the data, make it in our own formats, and that can be useful for us to extract the informations from the table. Some case, just an example, the next one is the unstructured data, like data which is non-unstructured, means we have some random data, but we can take the informations from some meaningful informations from the data sets. Okay, so by human intelligence, if you were try to do so, then maybe it will take more time, but if you take help of the AI, so we can reduce significant number of the time. Now some cases the vector data. Okay, so like this is, if you just think like if you want to create a vector informations, okay, by the manual process, you require a digitization. Okay, so which may require a more number of times. Okay, but in some cases there is a specific techniques nowadays is involved. Okay, from the real-time data we can generate the vector, the informations automatically. So then it can reduce the significant number of time to generate the data again and again and again. Okay, so that is how the geospatial industry is trying to use the different kind of vector data informations from this. Now there is another area which is called 3D. Okay, so in 3D, if you see that, like we usually create a lot of data sets in 3D in ArcGIS Pro. Okay, and there is so many other data sets will be there where we can create the 3D, but there is a lot of 3D, you can say what I said, nowadays lot of so much important informations which are extract from the 3D data, suppose for a CT level which we are actually monitoring. Okay, like digital twin is one of that part, like where we will get the 3D information as well as the 2D as well as the meaningful informations in a real-time mode which we can get and extract. So that is how the 3D information is more realistic, okay, and more useful for the present scenario, and that will possible when we will combine the AI in this particular field with this particular data sets. Okay, now this come to the real time, when as I just example giving you with the 3D data which will combine the real time informations, then it is so wonderful. Like if you see there is some kind of like we are working for just last week we went for a farm. Okay, so there we seeing that continuously monitoring is what, like there is a different types of data is coming from a different sensors. Okay, And we can put like for soil moisture measurement, for the soil conditions, then the chlorophyll content, everything we can monitor through the sensors. And the sensors, this data, this real-time data sets which is coming for every hour, suppose, okay, so that, so if you want to manually monitor, you have to sit in front of the data and you have to do the analysis. But if you make it as an automations with the taking help of the AI, okay, so and we already have a lot of our knowledge which will create as a trainings which we make set for the AI, and then we can use it. So then definitely it will be a game changing things which will. But as of now, what we are doing this, all the data sets which is coming, okay, that is continuously monitoring, and we are some kind of programming coding, we are generating it to get the alarming informations for us, where we need to take a more cautious for that particular field where the crop stress will be there. And it is going on in if you see I will show you one picture, like in US, in UAE, in Saudi Arabia, there is a big farms they have, okay, like it is a round kind of sprinkling structure. Based on the sprinkling structure is a round agriculture fields, very big, and that is a surrounding, all are actually the you can say the desert, and within between you can see this the agricultural land. So luckily I went there here, so we observed this, how this there's a combinations of the technology they're actually using to extract the informations. Now there is big data. So as you've seen here, there is a lot of this, there's a huge amount of data sets nowadays come, okay, so all this makes automations and extract the meaningful informations from the data. So big data is a very important part on that. Now next is basically the LiDAR. Okay, so LiDAR, if you see LiDAR data sets, if you go for the high resolution LiDAR, there is a size of the data sets will be the more, and there is an important thing is the feature extraction from the LiDAR data. So in that case also the AI is come to the pictures, and they are actually doing the auto feature extraction techniques. Okay, so that is what the future it is going on, and already it is, this technology came, it's required the more improvement. Okay, means if you see all these sectors which the manual intervention, the human intelligence, what we are actually using, slowly it is replaced by the AI. So now the question is how you have to utilize your intelligence to using this tool, and you make your productions more faster. Okay, so that is, it's not like that it will replacing you, it is your capability, how much knowledge you can acquire to use these tools and make your results more faster. Okay, so that is what it is going on. So now I'm just trying to give the category, okay, like in ISRI what it is going on around the world, also what is the people who are working in the different kind of AI tools, how they are actually focusing. First is the data types. So means using the AI, how different type of data I can process, extract informations. Okay, just like one, I just give you the LiDAR, which is a point cloud data. Okay, how we are going to do that? The next important thing is a feature extraction. Okay, so we will try to extract the different types of features from the images. Okay, so that means from images means satellite images or the aerial photographs. Okay, so either it will be the satellite images or it will be the aerial photographs. Okay, so we are actually trying to use the different types of data, like see aerial photographs is also there. Sometimes it is a drone oriented imagery will be there, and there is a very advanced technique that is called motion imagery. Okay, so motion imagery may be anything, like it may be from the CCTV camera, it's maybe from the drone which is monitoring it, or some kind of satellites also this capability to capture the video informations. From all this information, like if you go for this type of data sets, it's a huge amount of data, and manually you have to observe the data and extract information, so that you can take help from the AI and you can do the observations in automatic. I will show you one of the PPT. I have these options which we did it. Okay, so I will show you that. Now there is a kind of some kind of data sets which will be the bathymetric data. Okay, it's a huge level of data sets which is coming bathymetry. Okay, like sonar, by using the sonar or another technology, they are creating the bathymetric data sets. So how they will do the mapping of this? Okay, so in that area, so this is the data types where we have options to do different kind of AI studies. This is, you have to understand first. Now next is the task. What kind of task I can generate with the different types of the data? Okay, so task, if you see, first is the super resolution, like whatever the data sets I have, suppose I have a limitation of the satellite image, which is a resolution, either from the spectral, either from the spatial. Here, super resolution is most for the spatial. Okay, spatially we are suppose we are not able to extract the information. So in that case, we are trying to find out or create some task which will increase the resolution. That is what the super resolution is, how it is actually helping. Now next is another task is the classification. We know, like when we start doing the study in MTech or MSc in geoinformatics or remote sensing, we know like remote sensing means we are go for the classification. Okay, so this is the another task which we given to the AI, like you have to do the classifications. Okay, and it can do this very nicely. Okay, and then there's the object detections. Yes, pixel classification is not 100% accurate, but yes, in a certain level they are able to do that. Okay, so but it is not because of the high accuracy or low accuracy. I just trying to explain you about the AI's. First important thing is the data types, and second important thing is task. Okay, like from the data, what kind of task I can generate. Okay, so that we are trying to explain to the AI, or our mentality should be like this: how we will going to utilize the different AI tool with this data and what kind of task I can generate. Okay, so these are all the tasks which is already generated. Okay, just like if you see here the object detection techniques. Okay, like we did it here for the plum tree. Okay, so many of my colleagues in University of Dubai MBRC lab, they are actually did the plum detection techniques. Okay, but in ISRI also we have some kind of automatic detection techniques. Okay, plum detection. But the thing is, like ISRI tools, there is some limitations, like you can't change the model or something. But yes, that is also came. I will explain you last, but as of now there is a fixed model. Okay, like whatever my colleagues will be there, I will just going to share this particular knowledge with ISRI, and then we are combining our knowledge, and then we are trying to develop this particular tool for the country specific or the location specific tool. This we are trying to develop it. Okay, like some maybe I am not a programmer, but I have good concept of remote sensing and this deep learning tools, so which I explaining him or her, whatever my colleagues are there. So they are trying to understand the concept, and then we are trying to, you can say, enhancing this particular tool which we are actually using, so that we can generate a country specific tool. Okay, like similarly we can do for the prediction and classification. So we have a lot of classified data for huge number of times. Suppose I'm just giving you one example, like temperature classified data sets, okay, from the models we have from the long time. So using that data, can we do the predictions? Like we can use the data sets, like satellite data is now available for 40 years. So using data, can we do some kind of predictions? Okay, but then predictions if it is giving, so how much it will be accurate? It required validation. So now these tools are developed. Okay, results we need more validate. Okay, to enhance the capability of these deep learning tools. Now there is another tool which we will going to explain you, like segmentation. This is like image classifications. Like if I explain you the image classification techniques, there's a different kind of techniques. Supervised, unsupervised. In supervised we have different kind of technique like random forest, decision trees. Okay, spectral support vector machine classifications. In unsupervised we have iso chain, iso cluster. So all these different kinds of techniques which basically with a pixel based, but when we try to focus over the high resolution image, okay, so then our focus will be more on the segmentation technique. So in the segmentation, earlier when we are actually using for 10 years back, so we segmented the image, and then we have to create a proper rule set to extract the information. Now AI is very smart. Okay, so it can automatically segment it also, and it can extract the informations from the image also, target informations. Okay, so yes, obviously it is a different state level. We have a specific slide, that time I will explain you more. Okay, but this is what it is going on. So this is what that is called as a tasking. Okay, now the model. Okay, so on the basis of this, there is a different kind of model which is ISRI is already generated, or some different organizations like ISRO, like here here the space agencies or NASA, they are actually developing different kind of models. Okay, to make different you can say the task which can solve that particular objectives. Okay, just like to creating classifications. Maybe this they use like European Space Agency with their help, and then ISRI, they are combinedly did for that same kind of classification for the Sentinel also. That's why you are getting a 10-meter classified data for the full world. Okay, it's not manually done. It's a kind of a model, automatic model is actually used for that particular analysis. Then LiDAR vegetation classification, as is not because of the vegetation classifications. There's a because as the vegetation is very important in LiDAR data. Okay, so because the tree canopy, okay, then tree canopy height, all this information is very much required for different studies. As we are doing some studies for the mangrove, so there also we require a tree canopy height, or we want to calculate the biomass, then also we can require the tree canopy structure and all these informations. Okay, so that is how means AI will help us to do this analysis in a very fast mode. But if means what means you just try to observe and understand like this to creating the tree canopy, okay, from the LiDAR image, it's a complex techniques. And once you get that, then we can do some kind of high level analysis and research to extract some meaningful information like biomass and all those things. Okay, so now what the AI role? AI role is to make this processing, pre-processing will be more faster, which will be earlier it will be very complicated. Okay, so that's the way how we have to utilize the AI. Okay, so now there is a different platforms. As of now I am using these platforms like ArcGIS Pro, ArcGIS Server and all those things. Okay, like as I am so much influenced and trained in ISRI, so that's why I'm going to do that. But it's not like you have to stuck with this. You can go and explore as much as possible. Like we are here in a team, we are working for Python, we are working for the Gulat engine. Okay, so many different platforms will be there which you have to utilize and try to extract the information. But obviously whatever you are actually trying to do, so you just try to focus in a particular area. Okay, so that is what we have to do. Sorry, one of my colleagues is going to join, so that's why is anyway we can go for it. So this is how you can say the ArcGIS is basically the end-to-end the geospatial technology. Okay, so that is basically how the system is actually going on. Means here you see there's three things we are actually doing with the AI. One is the data preparation. First step is the data preparation. Okay. Second one is basically the data labeling. Okay, and then third one is the training the model. Okay, so what we will do, suppose my team, they are actually very good in the programming and coding. Okay, just like my team members, they are very good in coding programming. So what is my objectives? I just trying to prepare the data more faster way for them. Okay, and then we create some level. Suppose I am doing some model with suppose flood or some other technique, okay, like landslide, whatever it will be. Suppose I am trying to extract the information from the landslide area or flooded area. Okay, I classify it, I extract the slide area or the flood area and give it to him. So these slides, okay, or the floods, it may be useful for them for the data labeling. Okay, and then using that they can create the prediction tool. They can use this data which I did the classifications, that is like a brain which I generated for that particular model. Okay, and then we will try to the AI model to read from that particular data set. Yes, for that I can use for the multiple different types of years, so then it will be more good. So for that I can use for the multiple different country informations, that will be more good. Okay, so then slowly it will be so trained to extract the flood, so trained to extract the slides. So whatever the feature extraction, feature targeting, feature extraction, which we are actually doing, so that can be done by very faster mode. Okay, so that is what the take actions. Okay, so then once we will confirm with this, then we can go for the further things like deploying the models for the productions, then consume the models and the run in an interface as a scale. Okay, but that you see our data source always from the three different things. That is the images, like obviously satellites, it's maybe the drone, it's maybe the CCTV, or the taking the information from the mobile. Okay, so these are the different types of images which we are actually trying to do the creating the informations, or you can say the using the AI we will extract the informations from this. Now there is a different machine learning tools which we are actually use for sorry, the time is also going, I will just go a little fast, no problem. So machine learning tools which we are actually using here, classification tools which will be there, like if you see this, in case of the E3 we have the pixel and object based classification techniques. As I told you, like the different classification approaches will be there, a lot of different classification approach, which is the pixel based and there is a object based. So like if you go for the object based, okay, so that is a means you can say it's a combinations of the machine learning tools. Okay, it's a combination of the machine learning tools which will be there for which will try to create some training samples, which will give it to the machines to read, and then we will tell the machines to create more samples from this, so that we will get the more better informations. That is how the image segmentation techniques which we are actually doing in the ArcGIS Pro, like maximum likelihood, randomity, and support vector machine. These are the classification approach. As of now, it will be there where the machine learning tools is actually approved. Okay, so that's it. That's why I just mentioned these are all the classification approach which you can go and do. Now there is a clustering approach, which is basically the hotspot analysis, as is called as a hotspot analysis, or the multivariate clustering techniques, or density based clustering techniques, which we are actually using. And space based time pattern basically is a 3D kind of things, like where you can get X, Y, and the data information, as well as it is going to change with the according to the time. So that is also there. And there is another part, is called prediction model. As I told you, like some kind of like empirical bias kriging techniques, okay, like aerial interpolations, okay, which is helping us to extract the informations from the data sets. Okay, this is a time series data. So this is what it is. Now I will show you some imagery and its applications for the video analysis. Okay, so what kind of things it is will be there. So let's see. So now here also means what are the source of the data sets. Obviously one is aerial, drone, motion imagery, radar is also there, LiDAR is there, bathymetry, point cloud, feature and text. This is the different data types which we are actually using for our analysis. Okay, now the tools, first is the tool to power the end user workflow, second is pre-trained models to making the AI more accessible, and then third one is the API to train the AI models for that. Okay, this is how the deep learning we are actually integrating in this. Okay, the task, if you see, the task is already mentioned you, like what these are the data types and what kind of task we can generate, like object based classifications, okay, pixel detections, then image translations, object tracking. So these are the tasks which we can able to generate from the ArcGIS Pro, means whatever the deep learning packages will be there. So you will find those kind of things over there. Now deep learning tools which will be used for creating the DLPK packages, which use the, which you seen here, there is a different names which will be given. I will suggest you can go for it. If you want to go for the Python, then maybe you require these tools as a separate. Okay, but as of now ArcGIS Pro, it is already they created for the pixel classification. They are using this all the tools. Okay, like object detection, like car detections and all, you see these are the models, okay, which we are actually used. And then the intense segmentations, these are the models which we are actually using. And then the image transitions, which is basically the super resolutions, as you see, like data pre-processing. Okay, so which are whatever the 4 segments I told you, there's a different 4 segments. These are the tasks. Okay, like pixel classification, object detections, intense segmentations, and the image transitions. Okay, so these are the tasks which will try to use a different kind of AI models to do this particular task. Now this is transfer learning. As I told you, like we are actually trying to give like some models which I am generating. Suppose, okay, suppose there is a building damage area, or these are the building samples which we created. Okay, and then these building samples we are giving to the machines to learn from this, and it is create a more accurate information. So this is the one of the example on that. Okay, how the machines will generate, okay, results after transfer the learning. Okay, you see there is the classification will be more accurate. Okay, more than 90% it is good. Okay, now this is the one of the model which is nowadays very famous, like it is a Microsoft model, SAM. Okay, segmented augmented anything model. Okay, so segmented anything model, if you see, if you give any image, it will do the segment. This is a first level. This is a first level which is came. But the problem is there is no leveling over here. So it will be done by your knowledge. You have to give the label and you have to separate out the information from the SAM. Okay, the first when it was launched in 2.8, okay, so that time 2.9 I think it was launched SAM that time in ArcGIS Pro, but it was launched by Microsoft 1 year back. Okay, so then it is actually how they are actually pre-training it, okay, and we have to do the pre-training and we have to doing the extractions. This is what a SAM is. Now the next generation, there is a SAM 1, and which is basically the labeling, and that label which is came as a text to SAM, which is called as a generative AI. Okay, so where it is, just simply I will type it here in the image, extract car or extract the building. Okay, the same model, what it will do the model, okay, but it will extract only the car. From the segmentation, it will extract only the car and it will give it to you. So that is the most wonderful thing here. You see here, that is for the building. But again, when I am trying to use the SAM, you will see the good results over the permanent structures like buildings, like the car, like sheep. Okay, it will be working very good. But if you go for the tree, again it will be very difficult. You see here, that's why I give an example for the aircraft, car, buildings. Okay, obviously these are models is required the high resolution images, and 3 band is required. Okay, and 8-bit, it should be the 8-bit, then only this model will run, otherwise it will not run. Okay, so that's what we tried with the different objects. You see, as you see in these clouds, you've seen in small area it's work fine, but if you go for the large area, it may not work fine. Okay, so that is how, but it is a revolutionary, like text, just giving a text and I am getting the information extractions from the image. Okay, now this is the new enhancement. Okay, so this is one you see in like the before and after the cleaning of the images. Okay, it's basically, if you see, one is the super resolution. You can see it is increasing the resolution quality. As you see here, this is the resolution quality, it is increasing. There is a cloud, we can remove the cloud. Some case we have some black and white image, we can create the black and white image in a RGB format. That also we can possible to do. That is, we are actually doing. This is just for the visual interpretation. It's not, you are not expecting any kind of spectral information from the image, but visually it will help us lot of informations. Okay, now the next is the motion which we are actually talking about. Okay, this is a motion one where you can see the individual cars and moving, what is the different types of cars, the traffic information. We can connect it with our dashboards. We are real-time monitoring, and it is different kind of informations which we see in our dashboard. This is a combinations of the AI, the machine learning, and then the dashboard generations and enterprise. Okay, these are all the combinations how it is actually working. Okay, the same thing which we did for the farmland, which I told you, like in a farmland, continuously monitoring the soil moisture, then the temperature, everything. It's like a dashboards will be there where we are monitoring everything. Okay, this is useful for the precision agriculture also, this type of technology. Now the industry specific some use cases I'm telling you, like a few cases which I worked, okay, and a few cases which I just learned, and what is going on in the industry I'm just telling you, like just like AI where we are actually using for the shipware detections, okay, building point classification. This is very useful for that. Presently I worked for the flood modeling. Okay, so flood modeling or flood segmentations we can see. Okay, so flood segmentations also we can work, like crop classifications. Okay, so that also we worked. Okay, then some cases of cloud masking, but not successfully that much. Okay, but the blocks, streets extractions, it will be worked very nicely. Oil tanker detection, it will be work very nicely. Like water body detection, SAR, it is like what ArcGIS Pro, there is a direct deep learning tool which is given it here. It is worked very nicely. It can affect, it can more than 92% accuracy which is coming with the water extraction. Okay, then solar panel detections, also the tool will be there which we can be very useful, and it is working very nicely. Parking detections, it will be sometime it will be difficult, but if there is a car, it is very nicely it is detecting. Okay, but other cases it depends on the resolutions of your data sets which you are actually using. Okay, now there is another project which I worked that is called oil spill. Okay, there is a lot of problem with the oil spill, so we did some work over the oil spill, like radar image we can detect the oil spill. Okay, so there is a certain techniques which we call as a thresholding techniques. Using the thresholding, manually we will extracting it, but we will try to develop some kind of model which can automatically detect this oil spill and extract this information, which there is a DLPK package file is already there. Okay, so these are some example on that. Now in case of the forest, like we are worked with the plum tree detection as you seen here, but here in the plum tree, if you see This is coming under the some cases of precision agriculture also, like in plant tree we are trying to understand which one is good health, which one is bad health. Okay, so for that there is a different kind of techniques and the resolutions and the spectral bands which is required, which is useful to detecting the plant trees and all those things. Then the automatic tree counts. Basically I use the NV. Okay, there is a crop science tool. These two techniques I usually use this NV for that, because this two are the AI tools which is available in the NV software with the crop science module extraction. Okay, so then we can understand the different kind of tree health conditions using the crop tiles tools, and then we can detect the tree canopy also. This is also possible with the different techniques in ArcGIS Pro. DeepLearning packages is also available, but I get more higher accuracy with the NV tool. Okay, so that is what we need to generate, or you can generate your own deep learning package. Okay, so or deep learning module you can generate through the Python code also. Like plant species detection identifications, this is also very useful techniques. Okay, then these are the what I'm talking about, the forestry industry. What are the deep learning tools nowadays they are actually using? There is a lot of app you will found. Okay, which you just simply click the photographs of the tree leaves, it will tell you which tree it is. Okay, so that is how it is working on in your industry. And the detection of the forest. Okay, so this is obviously very important for the governments nowadays, because they want to see any kind of illegal capturing is going on there or not. Okay, so that we are actually doing it. Okay, so then there is a certain area which we are actually still working on, the mangrove. Okay, so to try to understand the mangrove cover extraction, so that we successfully did, but the main important and challenges is the mangrove health condition understanding with this kind of resolution data like we have as of now, the Sentinel, suppose 10-meter resolution. It's very difficult to understand the health of the mangrove if the patches will be small. Okay, but if it is a large patches, then maybe which is possible to identify the health condition also. Like wildlife, as I told you, like moving, lot of motion camera we are using to monitoring the wildlife movement. Okay, even the bird tracking movement also people are actually using these techniques. Now some cases, this area I just not work much. Okay, but this is a huge area where the utility area where the industry is actually working so much. Okay, like this is the area which I am not working, because this is you can say this is a utility part which is more on the like transmission, electricity, then pipelines. Here a lot of opportunities will be there. People are actually working with the feature extractions. Okay, asset identification techniques. Okay, so all these things are actually going on in a utilities sector. I am very much involved in the agriculture, like in ISRI and ISRO, all the area. I work for agriculture, disaster, a lot of things. So I'm trying to focus more on the different kind of AI tools which can be helpful for agriculture it is. So this is one of my analysis which we did. This is a free tool model which is available for IBM and NASA. They are actually developing model. So whatever we do the phenology analysis, if you know, like phenology analysis is very difficult. Like if we have to know the crop season of suppose November, December, January. So every month we will get the 2 images of the answer. So then we can calculate the NDVI. So suppose the 16 image, we can calculate the NDVI. You have to stack, and then we have to click over the 1 pixels over with the help of the ground truth, and then we can understand the crop phenology, and we are identifying the which crop it is. So this full technique, they created a model. Obviously this is for useful for this is a US scenario, but I tried it over the Indian scenario. Okay, and as you see this pink area now, so this is basically the grass. Okay, so that is their alfalfa grass, but this for our case it is actually the rice. Okay, both are actually looking like a same, like grass and the rice tree is looking same. So this model is classify it same as like. So why I'm trying this? Because this is, we just try to understand how this model is working for other scenario, and why it is classified it. So then we can find out some similarity between these two particular structure of the trees. That's why it is identifying like this. Okay, now there is the tools which is there in the ISRI software also, like gap detection, agriculture field delineations. Okay, this is a lot of place it is actually going to use it. Then tree segmentation techniques. This is good for the small area. In Indian scenario, I will not say it is very well working, because very difficult. For UAE, it is very good and well working, because every trees are very distance it is actually planted, so we can use these tools very easily detecting. plantation of the pit detections is challenging, but we did it in India. Some forest department, for some forest department, we are actually did this work. Okay, we somehow we did that, but it is always a challenging. If it is a more closest, then maybe it is difficult to identify that. Okay. So obviously it is not directly, if it is there is some process will be there like NDVI, or then we will highlight that particular area which is actually the pit is actually done. So then only it is possible to get a good results on that. Now the unstructured data. So this is the some area which I talked about, like a lot of data sets which is coming as unstructured. This is a very last of my my slides. Okay, so these are the some cases we will get some unstructured data. We will try to extract some meaningful information from that, like for auto ML techniques, then multimodal text input. Okay, fairness metric basic mitigation tools. Okay, so these are the lot of tools which is so you see here under the GeoAI, these are the two tools which is given through the E3. Okay, so that is helping you for this type of time series based analysis. Okay, so from the unstructured data you will take out some meaningful informations from it. Okay, so this is the same kind of like text extractions. Okay, so this is tool is also we tried. Okay, in a deep learning package is also it is available. Some cases it is very useful. Okay, which I found. Okay, but it's not 100% worked accurately, but it is giving a good results. So this is all about, you can say, the techniques which will be available for the AI and machine learning, which is nowadays means how the industry is going on. So I also explain you about the task. Okay, so and then accordingly how the model is actually developing. So if you are interested in this particular area, so try to think all the parts which I mentioned. So which area, like first you have to decide the application part, like if you want to focus on the agriculture, you want to focus on the urban or utility. First you select the domain, and accordingly you try to increase your skill, like how you are going to utilize the different AI techniques to solve the problems. Thank you very much. If any questions, please let me know. Yeah.
Thank you so much, sir, for your inspiring speech. We have really gained a mountain of knowledge through your understanding and perspectives. You have curated our minds with ideas and thoughts that we would definitely work on. Thank you so much. So now the platform is open for some questions, and I would like to invite my friend Srimant, who is ready with some few questions for the session.
Sure.
Firstly, thank you, Trishita, and welcome, sir, to SIGV Zoom platform. And so my friends have given me a short list of questions that are written down, and I'm going to ask you on behalf of them. So shall we start, sir?
Yes, sure.
So the first question is posted by my friend Sakshi Rai from MSc Geoinformatics. So the question goes this way: how can AI-driven Earth observation technology tools and softwares be made affordable for developing countries to address their unique challenges?
Yes, it is a very good questions. Like you see here, you should not go for like which I'm telling, like ArcGIS Pro. You have to go and you have to do this deep learning and machine learning techniques, or you have to develop these tools. No, it's not required. See now, as I told, like here I am expertise on that, so I am using this. Okay, but my colleagues, they are actually using the Python. They are using the you can say Google Earth Engine. Okay, so that is a free open platforms will be there. So you should utilize those platforms to extract the informations, and you can create your own tools which will be helpful for the societies also. Lot of people, if you go in following the LinkedIn, okay, so you will see a lot of the people, they are actually developing this tool and make it free for you. So you can use that tool also. Okay, it's not obviously you require your own knowledge to you can say modify this tool for your location analysis. So for that you require a good programming knowledge and skills. So if you have the good programming knowledge and skills, definitely you can go for it. Okay, so if you don't have the programming knowledge and skills, then you can go with some kind of this type of softwares which is coming, that you can rely on this. That's all.
Thank you, sir. So moving on, I have another question. This question is posted by Debisha Ghosh from and tech geoinformatics. So will AI really become one of the reasons of unemployment in future, mainly considering the low-skilled industries, thus by violating the sustainable development goals?
is, is a good very it's a interesting questions, but you see here like everybody is actually telling this thing like if AI will come then easy lose the job. Okay, so that is a very natural questions, but as you've seen here like I that time in my lecture also I mentioned like see the tools is there like we are doing the suppose digitization. Okay, it's a very time taking job. Okay, so but without digitizations I can't do any kind of analysis. I require the vector data for some kind of spatial modeling which I have to do and all. So suppose if I am using some particular person who is doing the digitizations, okay, so maybe that informations AI can generate in 1 second. So the person who is already only rely on the digitization techniques for the full lives, maybe they will lose the job. But the person who know how we can utilize that particular vector data for the spatial modeling to solve the spatial problem, they will not lose the job, because that is what the data scientist role it is. So the data scientist role will be increased more in the future. Only thing is you have to know that these all the AI tools, whatever the output it is generating, how to combine all these informations and how we'll solve some spatial problem. That is the most important thing here. Like suppose I'm just trying to work over the flood analysis. Okay, so suppose flood analysis, there is a lot of AI tools will be there. Immediately it will give you the layer where there is a flood is there. But then we have to give our knowledge to use that particular flooded layer, and we have to send these informations to the management like where suppose we required the shelter locations and all those things. We can generate it in a very easier way. How to reach the logistics during the flood situations, okay, by using the geospatial data we can do these things very better way. That means the importance of the geospatial scientists are increasing. Okay, so only thing is you have to understand, you have to increase your skill to think how the spatially you solve the problem with the taking help from this AI tools. So it will not losing your jobs, it will actually increasing you can say the work process which will be going earlier is a very slow, it will make as a very fast. You can take a very fast decision for any kind of things. That's all.
So this proves that no recession can stop us from getting jobs and all.
Exactly.
So now moving on, we have the other question. This was posted by my friend Sampurna Shah from MTech Geoinformatics. So what are the key challenges in adapting AI models trained on one region or sensor to other geographic locations or satellite databases?
It will not work. It will not work. As of now, whatever we've seen, okay, I am working for different types of AI models with the different countries. I've already tested. Okay, in Indian scenario, it is definitely not work. Yes, some kind of Western countries, these models are like little common because they have similar types of the building patterns, maybe some kind of vegetation patterns they are actually putting. Okay, so that kind of countries, maybe this model and tools will be giving a 70-60% accuracy, 70-80% accuracy, but in Indian scenario it will not give not more than 60% also. Okay, so that same kind of training tools which very difficult, just like that's what we are actually trying to do, like flood model, maybe it will be useful for all the countries, is it possible? So we tried this, but we are not getting the same results for the similar conditions. So that's what we have to consider.
Maybe in near future we'll
maybe near future we will get that.
So moving on to the last final question, sir. So this is posted by my friend Aniket from MSc Geoinformatics. So how can AI driven advancements in real-time earth observation enhances climate monitoring over next 5 to 10 years?
See, climate monitoring, it is already start working. Okay, so if you see Google Deep Space Mind, that is already there, and they are already working on the climate modeling. Okay, so and it is giving a very good results, like 80% with the 80% accuracy, it is actually predicting the results. Even I didn't see that results, but definitely I already read a lot of articles on that. Okay, so it is giving the good results. But again, the question is for the each and every country scenario, it is the same. that I have no idea, okay, because that we have to check that models will work similar for any kind of atmospheric conditions or not, okay. But whatever I just read from the articles, Google said that it is giving the very good high accuracy over that, okay. So that definitely it will be helpful.
Yes, sir. So this is the final question. Thank you very much, sir.
Thank you.
These have built a kind of inputs and insights for us. So
Yeah,
we'll be looking forward to keep in touch with you.
sure.
Over to you, Trishita.
Thank you so much, sir. Okay. Now my friend Yukta will end this session with a note of thanks. Over to you,
Thank you.
Yukta.
Yukta, please unmute yourself.
Am I audible, ma'am?
Yes.
Hello.
Yes.
Yes, sir. Thank you, Trishita. It's my privilege to deliver the vote of thanks for today's insightful webinar on transforming Earth observation with AI innovations and applications. First and foremost, I extend my heartfelt gratitude to our esteemed speaker, Dr. Suryadev Chakraborty, for sharing his expertise and providing us with deeper understanding of how artificial intelligence is revolutionizing Earth observations. His insights into AI-driven geospatial analysis, remote sensing applications, and the future of environmental monitoring have been truly enlightening and thought-provoking. I would also like to express my sincere appreciation to Symbiosis Institute of Geoinformatics for organizing this webinar and creating a platform for knowledge exchange. Special thanks to our faculty member, Dr. Gauri ma'am, Dr. Vidya Patkar, and coordinators and the technical team for their efforts in ensuring the smooth execution of this event. A big thank you to all participants for their engagement and the questions and their keen interest. Your presence and active participation have made this session even more valuable. As we conclude, let us take forward the knowledge we got today and explore new possibilities in the field of Earth observation. Thank you once again and hope to see you all in future discussions and collaborations. Have a great day. Thank you.
Thank you very much all.